welcome this video. After completing a description of the beta distribution and the triangular distribution, I'm going to give you an overview of the normal distribution. We're going to describe the distribution, and first of all, we will also talk about the normal distribution and its use. Then we'll look at the normal distribution, the average, the standard deviation, and the confidence intervals. And then we look at the expression and graphs of the normal distribution. The last element we'll be looking at in the standardized normal distribution and the S-value. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. First of all, I want to share something about the normal distribution and its use. The normal distribution is basically inspired by nature. And when we measure different parameters, let's talk about intelligence quotient, the height of people, many other variables or parameters, we found out, or people found out, that they are normally distributed. The normal distribution is a symmetric distribution, which means that the mean is equal to the mode and it's equal to the median. And it's applied in many statistical problems. For example, quality control, we're typically using a normal distribution. We will use this distribution to create a probability profile based on the expected cost and its standard deviation. Now, when we look at the normal distribution, there are three parameters that we are basically using: the average, the standard deviation, and we're also looking at the confidence intervals. So this is a normal distribution with a mean equal to 155 and a standard equation equal to 10. So we see that the mean, the mode and the median are at 0 here. Here we're looking at the Z values. I will talk about that later, but we see here the different values. And when we look at here, the yellow part here is the surface between the average and one standard deviation, which is 34.1%. But it's also not important not to forget that this distribution is symmetric. It means that when we look at the mean, the M is 155, and we look at the left, we have 50%, and we look at the right, we also have 50%. So now here between the mean and one standard deviation, we have 34.1%. When we look at the values and we say everything is smaller than the average plus one standard deviation, in our case 165, there is an 84% or 84.1% probability that the measurements will be smaller than 165. So basically that's what we are looking at here. The same thing for this distribution. For all normal distribution, the surface between one standard deviation and two standard deviation is 13.6%. And finally, between 2 and 3 standard deviations, we see that this is 2.1%. And when we look at the normal distribution, we also can define the confidence intervals. And the first interval is between -1, -1, and 1 standard deviation. So in this case, we will be looking at a value of x between 145 and 165. So this means that the surface between those two borders is equal to 68.2%. We can do that also for 2 standard deviations. So when we look at the 2 standard deviations, we know that this surface is equal to 95.4%. And the last interval, we're looking at 3 standard deviations. So we see basically that this surface is 99.79%. But it doesn't stop here. We're not at 100% because the distribution continues to the left and to the right. And opposite to the beta distribution and the triangular distribution, there is no minimum and no maximum value here. So that's the normal distribution, but it's clear the farther away from the mean to the left or to the right, the surface will approach 0, but theoretically in minus and plus infinity. We can also look at the density and cumulative graphs of the normal distribution, what we see here. Here we see that distribution, we have the same distribution that we had before, the distribution with 155 as an average and a standard deviation of 10. So what we can look at the table here, we have a table for different x values, and we have the value of the density curve and the cumulative curve. Now, when we're looking at the point 165, we see that the cumulative value is 0.8413. It means the cumulative value to the left of 165. To the right is 1 minus this value. Now, what we see here, or what we can use here, is that there is an 84.13% probability that the project will cost less than 165K. So that's what we can determine with this graph. And we can find a curve saying, okay, what's the probability that the project will be costing less than 120K? Well, it's very, very low. You see that. It also depends on the standard deviation, or the number of standard deviations to the left or to the right. And that's basically what we are looking at. The more to the left, the lower the probability, the more to the right, the higher the probability. We can also look at 180, and we can see that there is about 99.4% probability that we will not spend more than 180K. So this table gives you an overview, and we are going to use that later when we are looking at our 3-point estimates and the uncertainty aspect of the budget and the cost estimation. I also spoke about the Z value. The Z value, when we look at the graph here, we have now the graph expressed or to the left and to the right using the Z values. Now the Z value is x minus mu divided by sigma. Basically, what's the Z value telling us is how many standard deviations is x to the left or to the right. So when x is equal to the average, Z is 0 because we're exactly at the mean of the graph, and there Z is equal to 0, x is equal to the average. And the reason that people made this distribution, the standardized normal distribution, is that basically in the past it was very difficult to do all these calculations, and it would have been necessary for every value of mu and sigma to create a new normal distribution. But by standardizing the normal distribution around a value of 0 and expressing the x value as the number of standard deviations to the left or the right, we can use this for any distribution, normal distribution, for any value of the mean and the standard deviation. And that's a very practical way to work. Now, when we're using Excel formulas, we don't have to do this. We can use it. Excel offers the two possibilities. And of course, with the rise of computers and use of computers, this becomes very, very easy to work with. We don't have to calculate the Z value. But if we are using tables, the Z value comes in handy. So that's it for the normal distribution. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye-bye.